Let me begin with a word of prayer. Dear Father, we thank you for this day. Again, I thank you for this class. Just ask you to bless our time together. Help us to just understand a little bit more about how to graph functions and understand the graphs and everything. And I just thank you again, Lord, for your many blessings. In your name I pray, Lord Jesus. Amen. So yeah, I'm not collecting the quiz. Like, you guys get to keep it. If you're here, you get credit for it. If you're not, you don't. So how do I know if you're here? What's that?
We love you. You're the best.
I'm the best. I don't know about that. I'm pretty sure that's not right. I probably should be meaner. Let's see here. If you're talking to other people, make sure you talk about how difficult my class is and that they definitely don't want to take it because I'm like the most impossible professor on campus.
Is that what you actually want to say?
Go for it. Yeah, sure.
Is that like a compliment for you?
No, it's just if I get the reputation of being the hardest professor, then I have less grading.
Right.
Hey, I have a question.
Yes.
When I come to your office hours, you get mad at me for drawing arrows, but then you have arrows over there.
Those are different kind of arrows. All right, so. All right. I do actually have things to cover today, so let me move on here. So the first problem, you want to isolate a radical. I chose to isolate the radical with x plus 9 in it, and I left the 2 there because if I divide by 2, then I've got fractions, and I don't like fractions. So I just leave the 2, square it. That gives me this 4, of course, which then multiplies to give me 4x plus 36. I then isolate the radical again. This time I decided to suffer the fraction. I divided by 12. That gave me a 4th. I square it, and then I've got a quadratic equation which I can factor, and I get 2 solutions. And it turns out that they're both legit this time. They actually both are honest to goodness solutions to this problem. Okay, so problem 2. The natural enemy of the 3/4 power is the 4/3 power. And 8 to the 4/3, it turns out, is 16. So you get 2x minus 1 equal to 16, which gives you 2x equal to 17, which gives you 17 over 2. Now, I've posted a blank copy of this quiz as well as the solution in Canvas. So if you're not tracking this exactly, don't worry. It's in Canvas to look at later too, okay? This one here, you guys always have trouble with on the test. By the way, the reason I'm doing this, you might say this is kind of silly. Why don't I just not even hand a quiz out and just give you points? Well, that would be dumb. The reason for this is that this is giving you a window into my dark musings as I construct your test, right? Like, this is how I plot against you. These are the kind of problems I put on the next test, right? You know my schemes. I'm telling you ahead of time. These are the kinds of problems you'll see on test 2. All right? So figure out how to work them. In other words, learn the algebra. Now, so here I convert to fractional powers is usually what I do, like convert to exponential notation. It's a good way to go. So like square root is x to the 1/2, and if there was a cube root, it'd be to the 1/3 power. See that? So like 9/3, 6/3, but of course that's just 3 and 2. And then I gather everything together. 2 plus 1/2 minus a 3 for the x's, 1/2 minus a 2 for the y's. Do the math here, and my exponents end up being minus 1/2 and minus 3/2. So that's what I get for a and b in this problem. Any questions? Yeah.
Can you say again where we can find this?
Oh, it's in Canvas.
Canvas?
Yeah, under like module 7 this week. If you have trouble finding it, just let me know.
X,
I just posted it like a minute ago, so that's why it's not important.
when you do the x for the top one, like the x to square plus 1/2 minus 3,
Yeah,
down one more, that,
yeah.
don't you have to make sure they have all common denominators?
No,
Have to go together?
you talking about the exponents?
Yeah.
Well, I mean, yeah, but I didn't show the work. I mean, I just added the numbers.
So wouldn't it be 4 over 2 and then,
But that's a 6. So you got 4 plus 1 minus 6 is minus 1. 5 minus 6 is minus 1. Now, problem 4 is this a case-wise defined function, right? So the main thing is, which case are you in? If 2 is less than, well, f of 2, well, 2 is less than 3, so I'm in case 1, so I use case 1 formula, which gives me f of 2 is 19. On the other hand, for f of 4, I'm in the case 2. And so case 2, I use the case 2 formula here, 2 minus x cubed, which is 2 minus 4 cubed, which is 2 minus 64, which is minus 62. So there's that. Any questions? All right. And then here's the graphical one. I was disturbed earlier. I thought, oh no, f of minus 2 doesn't exist. There's a circle down here, right? But what did I not notice? That dot right there, right? That dot means, it indicates that f of minus 2 is actually equal to 4. Yeah, that dot will get me. That's right. So watch out for the dot. And then this circle means that 4 is not in the domain of the function, so that's why I've excluded 4 in the domain. But otherwise, you're going from minus 6 all the way over to 8 for the x's with the exclusion of 4. And the range, well, the y values, they start down here at minus 4, but it's not included. And they go all the way up here to y equal to 6. And 6 is reached over here, it's attained over here, but it's not reached there, but who cares? We already got it over here, so 6 does get to be included in the range, and that's that. Any questions? Okay, so that's a pretty standard collection of questions that I tend to put on your next test, you know, and that's part of why I'm giving you these quizzes, just to kind of give you a snapshot into the nature of the next test, and also just kind of a, you know, checkpoint on where we are. All right?
you don't include the negative 2 in the domain?
No, minus 2 is included. It's included because minus 2 is included in the domain because of this dot right here. F of minus 2 is 4.
No, for the domain, how come you don't put negative 2 in that?
Why
I
it?
wrote negative 6 for union with,
You mean 4? You mean why is 4 not in the domain?
no, why is it negative 2 in the domain?
It is. This minus 6 to 4 is an interval. That includes every single possible number between minus 6 and 4. So like there's an infinity of numbers there between minus 6 and 4. Like minus 4 is there, minus 2 is there, 0 is there, 1 is there, 1.5, 1.6.
Well, I thought because there was an open circle you had to include it, but now I see that there's a closed circle on negative 2. I just didn't see that.
Oh, okay. Well,
That was my score.
oh, okay. I got you. All right, so before I forget, while I got this out here, here's that unpleasantness. Now, one second here. Did I hand out the? I sent around the attendance. Is there a question? Why is there so much talking? I can't hear myself think. So there's the top hat. Let me do something more important. Did I prove to you guys yet that I'm Batman? I don't think I have. So, as you may or may not know, if you put Donald Glover into the Wu-Tang name generator, you'll get Childish Gambino, yes? What is less known, though, is if you put Batman into the Wu-Tang name generator, you get Thunder's Knight. But if you put my name into the Wu-Tang name generator, you also get Thunder's Knight. Therefore,
You're Batman.
I'm Batman. That's right. I'm Batman up to a Wu-Tang name equivalence. Yes. Go away. All right. How did I notice that? I have no earthly idea. I've forgotten. It's been a few years. I've been looking for other Wu-Tang equivalences, but I haven't found any to speak of. There's another professor here whose Wu-Tang name is Foolish Demon. I found that out. And there are many Wu-Tang name generators. That's the original one. There's a Reddit article if you want to study it. I don't really recommend that, though. All right. So we were talking about transformations of graphs. Yes, let's finish that. So what are the other 4 transformations? Good grief. If, rather, y equals to minus f of x is y equals f of x flipped over x-axis. Y equals to f of minus x is y equals f of x flipped over y-axis. And if you don't want to say flipped, you could also say reflected. Let's see here, what else? If we have y is equal to c times f of x, that is y equals f of x stretched vertically. And finally, if you have y is equal to f of cx, that is the graph compressed horizontally. So this adds to our repertoire of what we did last time in terms of how we can create new graphs from old. Let me show you an example. So like example 1, let's start relatively simple. Y is equal to 2 plus the square root of minus x. All right. So I will start with the square root function. All right. And then what does the square root of minus x look like? So square root of minus x, that flips it what? Over the y-axis. So it's like this guy. Okay? And then what do we got? Then do what? Plus 2. Is that vertical or horizontal? That's vertical, right? So then, so plus, what did I say? Plus 2? I'm too close to it. So here it is. There's y equals 2 plus the square root of minus x, something like that. So I take the original graph, I reflect over the y-axis to get square root of minus x, and then I add 2, and then I've found my way to the formula that we started with. So each one of these examples, I begin with what I want to create, and I show you how to get to it from the basic graph. So let me look at another one here. I'll make this one a little bit more complicated. Suppose we're looking at y equals to 2 minus the absolute value of 3 minus x. Now, there's various ways to go about this one. What do you guys think I should do?
What would you do?
Well, I don't know. I asked you guys. I would ask you guys, I guess.
I first draw through the absolute value normally.
And draw the absolute value normally by itself. I kind of agree with that. The thing, I'm not sure what to do about that 3 minus x, but you know, there's a property of the absolute value we could use here to make our life easier, right? The absolute value of like minus a is equal to what? The absolute value of a, right? So I can trade the problem I'm given for a slightly easier one, for at least for me to think about. This is actually the absolute value of x minus 3, right? Because 3 minus x is what? minus 1 times x minus 3, right? So I can absorb that minus into the absolute value, and then my life is a little bit easier. Then we can do what you were saying, which is to look at absolute value, right? And then we do what? We can shift 3, right, to the right. So there's y equals absolute value of x minus 3, right? Then what? Well, I don't think I have any compression or stretch in here. How about that minus, though?
Oh, it's flipped over the x-axis.
Right, so I'll draw that on the same graph because it's easier to see the reflection if I do it there. So it's like this, right? Here's y equals to minus absolute value of x minus 3. Right, what's this point right here? Yeah, 3, 0, right? We can kind of keep track of that point. That'll help us stay on the level. And I'm almost done, right? I need to do what then? What I have plus 2, right? So then I need to take that and I shift up 2. So instead of 3, 0, I have 3, 2. And it's still the same, you know, upside down. Well, I don't know what that is. What do we want to call this? Mountain? I don't know if hey, just a second. It should be more like here, 3 over 3 up 2. So it's like here-ish. All right, and then I guess it's something like, if I was doing it carefully, it'd be more like that. So there you go. That's the graph of y equals to 2 minus the absolute value of x minus 3. Does that make sense? Yes, no, maybe so? Would you like me to show you another one of these? Maybe one more. One more. Example 3. All right. So this time we'll look at y is equal to 3. Not 3, but rather y equals to minus 3 times the square root of minus x plus 2. This is kind of annoying, a problem. So I think to start with here, before I even try to do this, what I would do is to rewrite the formula a little bit so I can see what's going on. And so like my initial move here would be to try to factor that minus out. If I want to factor the minus out, how would I do that? Square root of minus parentheses x, then what? If I want to make that be equal to what's above it, I have to do what? Not plus 2, but minus 2. All right, so now I can see in my mind's eye like what I need to do here. Because I know it's going to be based on the square root function, right? It's going to be like square root function. I'm going to have to, well, let's just do it. So I'm going to write down the steps here. Did I ever move? Oh, you got me. You got me. So we'll start with y equals to the square root of x, right? And then we can go y equals to the square root of x minus 2. That is what, right? 2. And then I'm going to flip over y-axis, and I'll do that by y is equal to the square root of minus parentheses x minus 2. All right. Flip over the y-axis like that. And then what happened? Then I can do, I'll do the minus first, right? Then we'll flip over x-axis. That gives me a y equals to minus the square root of minus x minus 2. and not quite to the formula yet. Oh, this example is more beastly than I thought. This is a 5-stepper, and then stretch by 3. Now the stretching one, I have to kind of like, to do stretching properly, you need to like pick a couple points and kind of actually track them. Yeah.
With the stretching involved, is there a certain pattern? Because if you stretch it and then move it, it'll be different.
Well, there's certainly the steps here are not by no means unique. There are more than one way to get to the final formula, and I mean, if you take a different series of paths, as long as you get to the final formula, you should still get the same graph. But you're right, there's more than one way to do it. This is just a choice.
But there's no certain way you shouldn't like move it and before stretching, or you should be stretching before.
I mean, it's a matter of taste, really. I mean, potato, potato. You know. I guess I tend to try to get the reflections out of the way first, because if you shift first and then you reflect, you end up destroying the shift that you already made. So I would say try to get rid of reflections to start with. You know, that I would say that's probably a good advice. But another advice is, if it looks too complicated, forget about transformation by graphing. Just make a table of values. See, if you just pick about 10 points, 10 numbers to put into the formula, and you make a table with 10 points on your graph, you can make a pretty good graph, right? So the only reason that we're doing this is to give like a quick way to make simple graphs of the elementary functions. If it ceases being quick and simple, then go back to more basic methods of like just plugging points in and making a table of values, right? Which I don't even do in here in class because it's just too boring, right? Okay, so, or maybe it's just too hard for me, I don't know. But so here, y equals square root of x, we can move right to. So, all right, I'll try to do a little bit more than one. So I start with this, I move right to, right? So there's y equals square root of x minus 2. Let me number these. So this one is, this is 1, this is step 2, this is step 3, this is step 4, and step 5. So here's 1, here's 2. What's up next? 3. Flip over the y-axis, right? So I guess I'll keep doing things on the same graph until it gets too busy. Does that make sense? I think we can flip over the y-axis on this one still, right? So flipping over the y-axis does what? It takes this point right here, which was what? 2, 0, and it flips it over here to minus 2, 0. And like that. All right? So there's 3. That's y equals to square root of minus x minus 2. All right. What was my next move? Flip over x-axis. I think I'm going to opt for a new graph now. Okay. So flip over the x-axis. So I take that minus 2, 0 point stays fixed. But everything else, bloop. So like this, right? So there's your y equals to minus the square root of minus x minus 2. All right. Then what? So that was 4. And now I'm supposed to stretch by 3. So at this point, to properly stretch by 3 vertically, that means that you keep the x components the same and you multiply the y components by 3. So we need to pick like 2 or 3 points to make sure we do this right. Minus 2, 0 is easy. What like if I do minus 3, what's this point right here? If I plug in minus 3 into this, what do I get? You can plug it in down here, right? What we get? What? Minus 3 minus 2 is, oh, it's unpleasant, isn't it? It is minus 5, so we get square root of 5. Okay, square root of 5. It is what it is. What would be a nice point? I want this to be something like, that's a square. How about if I put in -7? That's over here somewhere, right? If I plug in -7 into this, what do I get? -7 minus 2, which is -9, and minus a -9 is 9, and the square root of 9 is 3. But there's a minus out here, so that actually gives me -3. All right, great. That's enough. We can use these 3 points to stretch. Probably we could have gotten away with 2. If you're just interested in kind of a generic picture, even 1 would do. So -2, 0, when we vertically stretch, what happens to that point? The answer is nothing. It just stays put. What happens to the point -3 times square root of 5?
Wouldn't it be negative square root of 5?
Yeah, that's minus. Thank you, minus square root of 5. My bad. Let's see, 2, 4. Let's take over here. So what happens to the -7 minus 3 point? It goes to 3 times -3, which is -9. So I don't know. If I had some graph paper, we could maybe do better, but it's hard to find graph paper on walls. -7 minus 9 would be that point. And the other one would be like -3 times root 5. If you guys had a calculator, you could tell me more about like what that is, but it's here-ish. So it's, roughly speaking, like that, up to the limits of my artistry. There you go. That's y equals to -3 times the square root of minus x minus 2. I don't think I've ever asked this hard a question on a test. But if you take this example and you take 2 parts of it, that makes a good test question, right? This had 5 parts. I typically ask 2 or 3 parts if I ask this on a test. Like 5 parts is a lot. Okay, enough about this. So what's next? Well, there's something I missed, right? There's something I should have talked to you guys about. Kind of basic, and I don't think I did yet, which is the vertical line test, yeah? So what's the vertical line test? Do you guys know? You know, so you guys already know, so I don't even need to teach it then. So you guys know what it's going to be? Tell me what it is.
Basically, if you have 2 points and they're on the same x,
2.
then they don't work.
Okay, so like if this is my potential graph, yeah, it's not a function. Why is it not a function?
Because it hits 2 points on 3 points actually on the y-axis.
Right.
X-axis, that's bigger.
Right. So the more formal statement is just if it fails the vertical line test if you can find even one vertical line that when you go through, that's supposed to be vertical line, it hits 2 different points, right, like that. See, because what that would mean, right, in this one, just hypothetically, suppose that top point is like, oh, I don't know, -8, 10, and that one up there is, say, -8, 12. Well, if this was the graph of a function, and then I asked you f of -8 equals to what would you tell me? Would you say, well, it's 10, or is it not 10? No, it's 12, right? Some other people would say, no, it's 12. Well, we can't have that, right? Like the most basic fundamental thing we assume about a function is it's single valued. So you can't have 2 outputs for the single input, right? And that's why the vertical line test makes sense, right? Only one y output for each x input. So this is no allowed, not a function. Okay. Now, oops, sorry. Sometimes we don't actually have a graph, right? We just have a formula. So like example 4, I might have something like, oh, I don't know, x, y to the 4th power plus x equals to 10. And then I could ask the question, is y a function of x, given that this equation defines it? So if this equation defines the relation between x and y, is y a function of x? How would you decide? Set y equal to x? No, I mean, kind of right idea, but more specifically, we should try to solve for y. If when we solve for y, we just get one thing for x, then we know it's a function. But if we don't, well, it's not. So I isolate, I get xy to the 4th is equal to 10 minus x. All right? And then I divide by x, I get y to the power 4 is equal to 10 minus x over x. And how do you solve y to the 4th equals to something? What do you do?
Fourth root everything.
The 4th root. And how does that work out for us? 4th root. If we take the 4th root of, what is, let me ask a more pointed question. I take the 4th root of both sides, right? I have the 4th root of y to the 4 is equal to the 4th root of 10 minus x over x. Okay, great. What is the 4th root of y to the 4th? Y is almost correct, but not quite. It's actually absolute value of y. It's absolute value of y. So the even root of an even power is absolute value. And so that is, of course, plus or minus y equals to the 4th root of 10 minus x over x. Lo and behold, we've got y is equal to plus or minus the 4th root of 10 minus x over x. And that algebra shows me what? That algebra shows me it is not a function. This equation does not define y as a function of x because there are two different solutions. Okay? Let me show you a really different example. Example 5. If we had, I don't know, x squared plus 1 times y cubed minus x is equal to the square root of 17x. There, that's kind of awful looking. Is y a function of x if it's defined by this equation?
Yes.
Yes, why?
Because it's odd.
because it's odd. Yeah, you're not wrong. But we need to work it out. So solve for y. If we solve for y, we get, x squared plus 1 times y cubed is equal to x plus the square root of 17 times x. So solve for y cubed. I've got y cubed is x plus the square root of 17 times x divided by x squared plus 1. All right? And then you're right. I mean, how do I solve this? I take the cube root of both sides. But the cool thing about cube root is it doesn't have the plus minus thing, right? The cube root of y cubed is just equal to y. And so that's actually going to be equal to the cube root of this mess.
So do you actually have to work it out, or can't you just look at the...
Well, yeah, I mean, it depends on the instructions, but if the instructions say solve for y as a function of x, and, try to solve for y and determine if the equation defines y as a function of x, then yeah, I want you to solve. There are some homework problems like this. Do you want to use the vertical line test on this one?
No.
Right, that's the question of do you want to graph this? I don't, right? No? Maybe?
Try it, Professor Phil?
Can we try it? Here, how about this one? Suppose you've got x plus 2 squared plus y minus 3 squared equals to, 64. Does this define y as a function of x?
No.
Why?
Because you've given us one odd, one even, and now you're just going back and forth to say no.
All right, but so are you guys choose? Do you want a graphical solution or do you want an algebraic solution?
I'm going to say algebra.
Algebraic, graph. I'll do both. So we've got y minus 3 squared, 64 minus x plus 2 squared. That gives us y minus 3 is plus or minus the square root of 64 minus x plus 2 squared, which gives us y is equal to 3 plus or minus the square root of 64 minus x plus 2 squared. And so the answer is nope. Not a function, right? Now can somebody tell me why that was obvious from the start? Well, you're going to say because it was a square. So if it's a square, it's not one. It's not a function. And if it's an odd power, it is. And you're probably not wrong. But there's an easier way here. This is a what? What's the graph? It's a circle. Where's the center? -2, 3. What's its radius? 8. So roughly speaking. And what's the meaning of the two solutions we just found? So like what's going on is the upper half of the circle, right? That is y equals to 3 plus the square root, right? And what's the other part? The minus is the lower half of the circle. So the circle fails the vertical line test, right? But that's because it's not the graph of one function, it's actually the graph of two functions, which of course the algebra also revealed to us. So the other thing I was supposed to tell you about today, and I have a minute, so I'll be brief, is we can also talk about even functions and odd functions. What's an even function? Even means f of minus x equals to f of x. Odd means that f of minus x is equal to minus f of x. So the even functions, the quintessential example of even functions, like y equals x squared is an even function. What's an odd function? Well, y equals x cubed is an odd function. The odd functions are said to be symmetric about the origin because they kind of like, they go through the origin if you look at the graph. But of course this is also an interesting question. You have some recommended homework problems where you're asked to like test whether or not a given graph is an even function or not. So we can talk more about that one some future day, but that's where we are. So next time I'll be talking about how to make new functions from old, like adding, subtracting, multiplying, composing. And hopefully that won't take the whole class. I'm hoping to start polynomial long division next time, so I hope you're there. Bye.